Let's just dive right into it. Today, we're exploring how one single word bridges the literal vastness of the cosmos and the future of global connectivity. It's the tale of two heliums. One of them was born in the fires of the Big Bang, and the other, well, it was forged on the blockchain.
I know, it totally sounds like a riddle, right? What on earth could possibly link the blazing surface of the sun, the super-cooled magnets inside life-saving MRI machines, and a revolutionary decentralized telecom network? Well, today we're going to look at a resource you probably think you already know all about, and we'll reveal how it actually behaves in ways that just completely defy reality. And that's true in both the physical world and the digital one.
Part 1. The Sun God's Element. So our story really starts in the physical universe, looking at the element itself. We're talking about the second lightest, and honestly, the second most abundant element in all of existence.
Helium rocks an atomic number of 2. Its incredibly stable nucleus contains exactly 2 protons and 2 neutrons. Now, from a cosmological perspective, this is wild. The vast majority of helium-4 was actually formed right after the Big Bang. Literally in those first few minutes, as the early universe was cooling down, nearly all the available free neutrons got trapped in helium-4 nuclei simply because it's just so energetically stable. In fact, today, helium accounts for a staggering 24% of the mass of all ordinary matter in the universe.
But the timeline of how we actually found it is full of surprises. Get this, humanity discovered helium in the sun decades before we ever found it here on Earth. Back in 1868, during a solar eclipse, astronomers detected this unknown yellow spectral line. A guy named Norman Lockyer concluded it was a brand new element and named it after the Greek sun god Helios. It wasn't until 1881 that it was finally detected on Earth during an eruption at Mount Vesuvius, and then isolated in a lab in 1895 by Sir William Ramsay from a uranium ore called cleveite.
Moving to Section 2, Quantum Liquids and Superfluids. Because, look, beyond just filling up party balloons or blimps, physical helium's properties are truly mind-bending, especially when things get extremely, extremely cold.
For starters, it holds the record for the lowest boiling point of any element, sitting at 4.222 Kelvin. But here's where quantum mechanics steps in and makes things super weird. Helium flat out refuses to freeze at standard atmospheric pressure, even at absolute zero. Its zero-point energy, which is basically the inescapable underlying jitter of its atoms, is just way too high to allow freezing unless you apply massive external pressure.
And it gets crazier. If you take this liquid helium and cool it just past its lambda point, which is around 2.17 Kelvin, it transforms into a phase called helium-2. This is a bizarre superfluid. That means it's a quantum liquid that flows with exactly zero measurable viscosity. None at all.
Because it has absolutely zero friction. Helium-2 will form what's called a roll-in film and literally creep up the walls of a glass, completely defying gravity just to escape the container. And if you heat up a special chamber of it, the pressure change causes it to fountain upward endlessly. It is a literal macroscopic display of atomic quantum mechanics happening right in front of your eyes.
Which brings us to Section 3, the helium scarcity problem. So, the absolute crucial point here is that while it's super abundant out in the stars, terrestrial helium is incredibly rare. Down here on Earth, it is generated very, very slowly by the radioactive decay of heavy elements like uranium and thorium deep underground, which eventually traps the gas in natural gas fields. And we rely heavily on that trapped gas. Liquid helium's ability to stay incredibly cold makes it an absolute game changer for modern tech. A massive 25% of our entire global supply goes straight to cryogenics and cooling the superconducting magnets inside MRI machines. Another 50% goes to industrial uses, like manufacturing the silicon wafers inside all our devices, or acting as a protective atmosphere for arc welding. We are burning through massive amounts of it every single year.
But, here's the major problem. Because it's so incredibly light and chemically inert, once terrestrial helium is released into the atmosphere, it doesn't just hang around. It bleeds right out into space. That makes our earthly supplies strictly finite, totally non-renewable, and rapidly, rapidly depleting.
Section 4. A digital helium network. Now, let's pivot and see how these exact principles, utility and scarcity, that totally define the physical element have inspired something radically different over in the tech world.
Just think about a telecom industry for a second. It is a massive $3 trillion global market, and historically, it's been controlled by just a handful of giant corporations. Well, the decentralized helium network comes along and flips that centralized model completely on its head.
instead of some massive corporation building out all the cell towers. The Helium network is this open, community-built wireless infrastructure. It's literally powered by everyday people. The whole ecosystem includes the network itself, Helium Mobile, which actually offers phone plans on the network, and the whole thing is driven by an economic engine running on the Solana blockchain using a native token called HNT.
And the scale here is just staggering. We aren't talking about some small proof of concept anymore. There are over 2 million active users daily. Over 99 terabytes of data are transferred across this network every single day. To put that into perspective, that is the equivalent of streaming 20,000 movies. Major telecom carriers and global enterprises are actively relying on this community-driven infrastructure for open connectivity.
Section 5. HNT Economics and Scarcity. Just like the physical element has to be painstakingly extracted from the Earth, the digital token, HNT, is mined by its users. But the mechanics behind how it actually maintains its value are absolutely fascinating.
So anyone can buy a Helium hotspot, set it up in their window, and provide wireless coverage to their local area. By building out the network and connecting nearby devices, you earn HNT tokens. But here is the major twist. To actually use the network to transfer your data, HNT must be permanently burned. It is entirely permanently removed from circulation.
This setup creates a really powerful tokenomic model called a burn and mint equilibrium. As more and more devices connect and data demand grows, the network is actively destroying the digital resource. Just to give you an idea of the sheer volume, during one recent day, over $44,000 worth of HNT was permanently burned out of existence simply to fuel network usage. Much like our rapidly depleting physical reserves of elemental helium on Earth, digital helium relies on strict, mathematically enforced scarcity. There was no pre-mine when it launched back in 2019. It's actually deflationary right now, governed by a very predictable 2-year halving schedule, meaning the amount of new tokens created gets slashed in half every 2 years. And it has a hard, unchangeable cap of exactly 223 million tokens. Once we hit that, there will literally never be more.
Section 6. Two Heliums, finite futures. Now, as we step back for a second to look at the big picture of this explainer, the conceptual parallels between these two incredibly distinct domains become undeniably clear.
On the one hand, you've got a cosmic gas, forged in the literal Big Bang, that completely defies friction, cools our life-saving MRI machines, and inevitably escapes our atmosphere into the void. On the other hand, you've got a digital token, forged by a totally decentralized community that defies traditional telecom monopolies, powers global connectivity, and literally burns itself out of existence just to function. Both of them provide absolutely immense utility, and both are completely defined by their absolute limits.
Which leaves us with this final thought. We live in a world that is entirely dependent on endless growth and consumption. So whether we're looking deep underground for the physical gas that cools our bleeding-edge tech, or we're looking to the blockchain for the digital tokens that connect our devices, how are we going to adapt to the ultimate scarcity of both the physical and the digital helium?